Welcome to our lab exercise where we will be introduced to using a Pita tube and manometer to make pressure and flow velocity measurements. The apparatus consists of several components. First, we have an air channel with a fan connected at the end. A Pita tube is connected to the channel to measure static and stagnation pressure and also flow velocity. The Pita tube is connected to a digital manometer which displays pressures in inches of water while outputting a voltage which is captured by the data acquisition system. The calibration between voltage and inches of water will be given to you by your instructor. This is a close-up view of the wind channel. It is also important to observe that the Pita tube can be adjusted vertically, and it can also be adjusted by rotating at an angle in the horizontal plane. Let me demonstrate. Vertical movement, up and down, and it can also be rotated at a desired angle. The Pita tube will be placed in the center of the wind channel, allowing us to monitor the velocity profile in the channel. This would be done by moving the Pita tube vertically up and down the channel. The output of the digital manometer is connected to the instrument data acquisition system. This allows data to be transmitted to the CPU and results can be saved and analyzed. Thus, the calibration of the digital manometer must be known prior to performing the experiment. Before starting the experiment, we would first need to remove or record any zero errors from the digital manometer reading by setting the output display to a 0 value. So to recap our apparatus, we have our CPU, which is connected to our data acquisition system. We have our digital manometer, along with our flow channel, which is equipped with our Pita tube. At this point, I will now illustrate what an actual Pita tube on an aircraft looks like. The picture illustrates the Pita tube used on a typical aircraft. And as you can observe, it has a similar shape to the Pita tube used in this experiment. If you look closely, you will observe that there are several small holes around the diameter of the tube to monitor static pressure. The hole directly in the front of the tube monitors stagnation pressure. So in reality, it's a tube within a tube. As you move along the Pita tube, you will observe some ports at the end. These ports monitor static and stagnation pressure, and the difference between these will give us dynamic pressure. Now let's begin the experiment. The procedure will be as follows. The experiment will be done with the Pita tube initially at the top of the channel, which is 5 inches in height. We will then adjust the Pita tube in increments of ½ inch going down until we get to the bottom of the channel. This will allow us to generate both velocity and velocity profiles in the channel. We will be observing and recording static, stagnation, and dynamic pressure at each height of the channel. Now, let's begin the experiment. So now that the system is configured and our manometer, our digital manometer is roughly at 0, we would recognize if we have any zero errors within the system, and we would go ahead and save this information by hitting start, and then we would save as 0. So at this point, we would adjust our Pita tube to the extreme top of the channel. And our Pita tube lines are already connected to our manometer. We would then turn the fan on. And we would proceed by taking our first reading. So we would go ahead and hit start, save, and we would record this as 0 inches. Then we would adjust our Pita tube down to half of an inch. Hit start and save as 0.5 inch. And we would repeat this process in increments of half inch and keep saving. Start, save, 1 inch. And of course, we continue the process. Start, save, 1.5, we're now to 2 inches. Start, save, we're at 2.5 inches. Start, save, now we're at 3 inches. Start, save, three and a half inches. Start, save. Now we're down to 4. Start, save. We're getting close, so now we're at 4.5 inches. Start, and we save at 4.5 inches. And then finally, we're to the bottom, so we go all the way down to 5 inches. So we start, save, and now we can turn the fan off. So at this point we have recorded several different values in increments of ½ inch going down. So the experiment is complete and you'll be getting your data from your professor. Thank you.